and why are you here?
Yeah, great question. So I'm Monish Kamlaksha, and I'm a manager at a 5G R&D company by the name of Make My Technology. So to answer your second question, why I'm here is to do something that I think is quite weird, but here to establish a 5G ecosystem.
5G ecosystem?
Yeah.
Okay. So my next question, we hear about a lot of these 5G labs,
right,
and a lot of university activity around 5G.
Yeah.
What's so special about 5G?
To answer your question of, what's the hype or the craze about 5G is, I could say that this term called the latency. So basically what it does is, basically the speed increased, right? So whether you're sending data signals, text, or any form of other data, it is quite fast. So if you're doing a video call, earlier I think over the 4G or the 3G, you would have static imagery, but now that has come down in terms of telecom. But now its introduction into the 5G lab setup that you just spoke about is in terms of research and training, right? So it's quite of a fancy term like the AI that has come in. But other than that, it is something that it is booming. I would say that because of the massive reduction in having the 3G system that was really expensive and big. Now you have something you can put in your backpack.
Mm-hmm.
So
compared to 3G, 5G is a lot more compact, I understand.
Yeah.
Right? What are the other things?
The thing is, commercially we are trying to depend more on robots.
Mm-hmm.
So one of the ways to control them and to have the scale intact is to use some large coverage networks such as 5G.
Okay. Let me break it down again, or let me rephrase the way I understand.
Right.
For example, up to 4G, I can watch YouTube video.
Yeah.
As a commercial, as a user,
yeah,
common man, I can watch YouTube videos. In 5G, it's a lot faster.
Yes.
Okay. But certain areas where I have personally experienced the telecom network breaking down, for example, when I am in a concert.
Yes.
Right. When I'm in a concert, and I want to share that experience with the world. Right. I want to shoot a selfie of me or a video of
Absolutely.
mine, and I want to share it, but it doesn't happen.
Yeah.
Right.
Yep.
So a part of 5G
Yes.
addresses that.
It does.
Okay. So can you take us through how?
Okay. So there is this concept called beamforming. Okay. So beamforming is a part that, like you just correctly said, stadiums or concerts. So these are big enclosures, but they're again a closed concept, right? So what happens here is, so we use these circular antennas concept where the antenna is in the form of a sphere, okay, which has these several antennas inside the sphere which do beamforming. By beamforming, it's like a spotlight. So you know how when you on a torch, you have this conical display of light that goes and shines on a particular on a particular element, and that's how light travels. So imagine the same, but now with network, with data, right? So you're in a concert. There are people shoulder to shoulder with you, right? Now what happens is the spotlight directly falls on your UE, on your handset, right? And the people beside you. So you're covered in one spotlight. Similarly, it happens in types of a cell configuration, and all the people inside a closed space who are actually shoulder to shoulder get equal, data rates.
Equal data rates.
Only possible with 5G.
Only possible with 5G, and 4G typically breaks down.
Yes, but it breaks down.
Okay, like I've been to multiple concerts and I have never managed to hear even a 5-second video out.
Absolutely. I think you can only have the memories.
You can only have the memories. Of course, you record and come back, but then sharing this, this concert is about to start.
Exactly. It doesn't happen. Yeah. Something about it.
Yeah. So that's the scale, right? Like so many people have that dedicated bandwidth and they are able to enjoy.
Yes.
The second aspect of it is IoT, as you mentioned, IoT, where like I have a large scale IoT deployment and massive machine type communication.
Yes.
That's another thing that 5G solves. And the third aspect is this low latency game.
Yeah.
Okay. And this what they call as this URLLC.
Yeah, URLLC. Absolutely.
And further breaking it down, right? Like from a use case point of view, what I see is globally people who are mostly the private 5G players seem to come towards URLLC more.
Yeah.
Why is that? Can you tell us?
Okay, I could not give you a proper point, but okay, what my understanding, let me just tell you my understanding of this, right? So there are some of the key players in the Indian market. Let's not name them. Okay, but the main reason they come for that deployment of low latency is actually in terms of giving us, how do you say, it's not a form of entertainment alone, but it's more of a wow factor. Right, because when you talk about the telecom sector, it's a service sector. Okay, it's not an application oriented sector. It's not where we are giving you a solution. Okay, what we are trying to solve in the telecom sector is just that you make a call. That is what has been the lifeline from a long time. Okay, now it's just that we are expanding into different domains.
So it's a use case that the telecom companies don't understand.
They do understand, but they don't want to utilize it because that's not where their business would like.
They don't see a big business there. Big business there.
Right.
On the other hand, the industries that come in this direction,
right,
they see value in this technology.
Yeah, absolutely.
So what is that value?
The value is that you have a system that doesn't break down on you. Let us just say that, right? So because see, with the 5G, let's just talk about the GNB now here. So the GNB is a compact rugged module that you could place, I think, within a room or within just a building, and then have connectivity that doesn't default even if there are 1,000 people using the service. I mean, the GNB that I have worked with supports 128 simultaneous calls, right, and 1,000 subscribed users, right? So that is just inside a small building, right? So you just spoke about concerts and areas of small, group density. So in such kind of places where your peril was that you would want to have the same speed, you would want to send the video when you're enjoying the moment. So such kind of places, it's more of a small interest groups, let's just say, right? So that is where the outside people actually want to put their money in, but not the big industries, because it's obviously they get to service more than 1,000 people.
Yeah, again, I think we are tending more towards the massive user base and bandwidth, right?
Right.
The enhanced bandwidth.
Yeah.
So the DMMC, right? Enhanced mobile bandwidth.
Right.
But then, what is this URLLC? What is that driving us?
Okay,
the low latency.
Okay, the low latency. Okay,
so, I mean, do you see interest? I mean, among the people you meet, do you see that interest group here around in India?
Yeah, among two verticals, the defense and agriculture. So, okay, so in India, right, we have the drone craze. Craze. Right, so over there in two fields, that is the defense, we do use drones. I mean, and in agriculture, we are now having the pesticides and everything sprayed by them. Right, so as you said, low latency, drone is a product that requires this. It's called as okay, let's just take the name of drone corridor, where a drone actually has to pick up a cargo from one particular, this is an enclosed space, by the way. So it needs to pick up a particular cargo from, say, place A and deploy at place B. But now the main problem here lies is that it travels, I would not know, you cannot quote me on the exact how much kilometers per hour it travels, but let's just say it's quite faster than you walking with your phone, right? So at that time, this is where, the low latency picture actually comes in, because you would have to have the handover, which is actually when a UE crosses one cell to another, right? You need to have the same quality of service without breaking. So that is where we actually see. So it's in the department of drones that I have particularly crossed across in both agriculture and defense.
Two massive use cases, right?
Yeah.
Two massive use cases. And apart from drones, do you also see people in supply chain asking questions about this?
Okay, so supply chain, would you mean warehouse management?
Warehouse management.
Yes. Okay, it's good you asked about warehouse management. So until now, I mean, I've heard of use cases in the industry where, they do connect these more like a Roomba bot situation, which is Amazon. Let's just talk about Amazon warehouses. They do install such devices which take care of the IoT. So that's an IoT integrated space, right? So that is one of the use cases that actually happens. But yeah, we have seen, but in India, not I haven't come across.
You haven't come across.
No.
Okay. And then coming back to the college cases.
Yeah.
So what brings you to an educational institution?
Okay. Now we just spoke about the industry and how it actually aligns with the requirements of an industry, right? And now now we switched our topic back to something that has been rigid for a long time, right? The education system, but is trying to be flexible and growing. That's really something great. So here what we have found is, so there was this a big gap in the telecom industry, or the engineering degree of telecom, okay, that actually couldn't afford the 3G system or the 4G system in their labs, right? But now I think it is because of, you know, this really shoot in the processor market, that we have been able to get chips that we can actually manufacture GNB solutions and give it at a low cost price. Because let me tell you, when it comes to education institutes, right, we have to keep the money part in mind. Because let me tell you, they are not putting it out part as a service, right? It's more of a research institute. The main agenda and aim at the end of the day would be to only put it in research, right? So integrating it into a research institute is first to educate people, right, and to open portals, right? So the another drawback of the EC, which we call as Electronics and Communication Engineering Department, is that it fills two job portals, embedded and VLSI. But the irony is that in the name, communication is there, right? So here we are trying to open such doors, right? Having a portable solution is one of the ways to do it, right? Another way would be to educate the masses that such kind of a career path is also available.
Right. Okay. And assuming private 5G takes off, and or a massive amount of IoT scale deployments happen, and another technology name that always gets associated with 5G is edge computing.
Yes.
So what is, I will come back to the university, I think we're not done. We'll come back to that, but then what is this
edge computing?
Closely knit relationship between edge computing and 5G. So whenever we talk about computing, particularly in the Industry 4.0 world, we are not comfortable taking it multiple hops and then taking a control decision. Right. Okay. So whenever we want to have a closed loop system, we prefer that closed loop to happen as
as quick as possible,
as closely in an architecture term, right? It has to be a very small closed loop. So that's where, you know, this private 5G is very interesting for the industry, and then trying to have the MEC within my premise, and also having the edge device compute inside my premise helps me. And then if I'm going to build a low latency application, then I'm excited. Then the kind of flexibility I have, the traditional PLC ends at a particular line. There is an invisible barrier between a PLC and the office network. But then now I don't have to worry about it. I can have a private network and then an edge box, the MEC and the edge.
All in one closed loop.
They are very close to each other, and I get a more reliable low latency. That's something that's available. And that's, I think, also the great place where we can give it. I mean, what excites me is when I see that you are enabling faculty members, and when you are enabling students, then now they can play with these new use cases.
So just not play. I think the term that we use here is that they break the system. They break the system. I think the only way you can learn is by breaking a system, right? By reverse engineering it. The word engineer is in it. So that's the thing, right? Because until earlier, it was quite a costly affair even to think about the telecom domain. But now that's what, not just the faculty, we also want the student more integrated along the verticals. The education, when they had the Center of Excellences formed, it was quite recent. The Center of Excellences in colleges especially was quite recent. But now again, that has also somewhere stopped, right? You don't see them coming out with a product. You do understand that they have a Center of Excellence and that they do projects within it, but they don't want to come out with a product, right? But the industry requirement is quite separate. The IoT is still a relevant use case, right? So is the drone, so is the other verticals as well.
AMRs, autonomous mobile robots.
Everything is. But the thing is, there is this invisible boundary, that I think is not being able to cross over by students and faculty. So we are trying to break that boundary or cross that boundary by bringing our equipment into the current infrastructure that is there.
In other words, the solutions and market needs are becoming more networked.
Yes, more networked.
And more networked, and for students and to break in and understand these complex landscapes. 5G being a more open technology,
yes,
it paves the way. It paves the way.
Yeah.
And also because it's more layered, people can understand it more easily compared to the earlier ones. It's also a lot more compact. And it can also be privately used.
It can be privately used.
So there are so many things that a student or a faculty can hit the checkbox and say, hey, this is something I can play with. And for, as you said, in ECE, electronics and communications, that communication
it has gone missing for quite a long time.
It's been missing for quite some time.
Absolutely.
Now. I mean, because the number of jobs where
I think it's because of the industry does value your time hands-on, rather than on the theory knowledge that you accumulate over the years. So that is more of a thing that you have with 5G as well. Now, since you just said, I would like to add, it's more of a multidisciplinary activity, right? This is not just for the EC. I think I just took out the thing for EC, but the 5G core, which is the brain of the entire network, is something that the students actually develop, that even the company that I work for is developing by itself with the students. So we are doing that also as a separate project. They call it the capstone project. We are developing that as well. So where you have not just reserved it for the EC students, you have something for the CSE, you have something for the EEE, you have it for all branches.
You can actually run HTML and
yes, absolutely, right. And the thing is with, let us just even put out the word 6G, because it's catching a lot of eyes, and people do ask me on a day-to-day basis when I meet with clients and everything, hey, what about 6G? Although the reality is that we are far away from 6G. That is the truth, even from industry standards, because I don't think the standardizations for 6G have come in. They haven't. Okay, so that is more of a 2030 case, even for India as a whole country, and for the global standards. Okay, so even when that comes in, 5G will serve as a really strong backbone. So if you do not have your your basics covered, I don't think you would be making that jump quite easily as other countries, as our neighboring countries.
So as you were mentioning the number 6, the immediate thing that came to my mind was Wi-Fi 6.
Oh yeah, the Wi-Fi 6. All right. Yes.
So how does it,
whether it's a parallel or complements the system,
or it can compete, and in private installations, maybe Wi-Fi 6 is all that you need. You don't need 5G. All these kind of questions
do arise. You're right about it, but see, the thing is, the 5G is not just known for being a network capturer, right? It's not just about the speed. It's all about using it for different use cases. So which means that if I run 3 drones together on one GNB and then have people even doing normal phone calls, it wouldn't make a dent on the network. But Wi-Fi 6 couldn't promise that. It couldn't, right? Because the architecture doesn't support that, right? The 5G core has 10 different functionalities, right? Which each has its own individual role, which can actually right from registering a user, which is your SIM card, to actually facilitating services just to the dedicated person, right? So here, when you have such a kind of a strong capability of a network, using Wi-Fi 6 could work out somewhere if you have just
some confined requirements. It works beautifully, but
then you wouldn't have a bigger.
When you want to have multiple towers and handovers,
it would be a difficult concept. Absolutely,
it'll be
and you cannot take it over long distances. Basically,
the geography, as long as it's a limited geography,
you could work with an IoT kind of a surrounding.
Again, with 5G, we need to have something like URLLC.
Yes.
If you are going to connect machinery that depend on time,
then you would have to have all those connected within it, and it's easily configurable. So with 5G, right, you do not need, because I think 5G also has a more community environment, I think, because there's an open source community that works in developing the 5G core. It's called as Open5GS. For those who don't know, it's Open5GS. And that is stable version. Several colleges do use it. The research universities abroad also do make use of it. So such kind of systems weren't there before, right? So not in just in the domain of telecom, but moreover, even in this day and age, nothing stops you from developing your own network. That's the thing.
Yeah. I mean, it all started with Linux becoming carrying the open source baton, and
absolutely.
Then seeing the success, now it has come everywhere, and of course TCP/IP, it being an open protocol, succeeding, and then like otherwise the RAN, say 4G RAN, it isn't as flexible and as easy for a newbie or a new person to walk in, learn, and build solutions, build
it isn't. Now that you just said about Linux, this is just something that I want to put out. Even though I think it's a problem of Indian engineers, right? We are not taught on Linux, right? So even though Open5GS is a Linux based, because that is how it works. The core is much stable on a Linux rather than on any other OS, right? We are more of a disabled crowd when it comes to working with Linux. I think the industry does make use of it and spend its time on grooming the freshers when it comes in. But this is where even
in college it is absent, non-existent.
I think because this is an interaction I had with a particular faculty from a reputed college who I think rejected the solution because it was Linux.
That's something I don't understand.
Right.
I come from a EEE background, electrical and electronics background.
Right.
And the first time I used Linux was 1999.
Oh, okay. Wow. Okay.
So, and it was love at first sight.
Oh, really?
Okay, yeah, 1999. I picked up the CDs from a roadside bookshop in Bangalore.
Okay, that doesn't happen now. I'm just letting you know that doesn't happen now. Okay. I'm trying to relate, but it's quite difficult for me. Yeah.
It's 1999.
Okay.
So.
Yeah. Okay.
But then I was the first Linux user in my college.
Oh wow.
Okay, that's how we came into this. But when I walk into multiple institutions and when I talk, everybody talks a lot about jargons, but we learned every basics. I mean, if it's graphics,
right?
We went into the depth, and it was Linux operating system. If it was networking,
right?
Linux. So, and then when we learned everything with an open architecture, and now when I see 5G,
right,
and I see an open architecture, like the kind, I'm able to imagine the kind of use cases students can build.
Okay.
Students can build, and the way...
You're absolutely right, when you say that, because we have a concept called as core slicing. So slicing, the network is quite different and the core slicing is quite different, right? So the 5G core, which is again on a Linux system, can be split. So the architecture, all the 10 functionalities can be split, and you can basically play around with it. And because since it's Linux, it's open source, you can use it however you want.
It's also a microservices based architecture.
Yes,
you don't normally relate it to Linux, but it's a microservices based architecture.
Right. Yeah. But the thing is, again, since it's absent in students and faculty, it's not just the students, it's the faculty as well. And I think even I am, I fall in that circle as well, because whether it was my engineering or whether it was my schooling, the word Linux was something that I've heard, but not something I've played with. So I cannot relate to you playing with Linux and being the first, but Linux as a whole was, I think, only taught in the computer science division, right?
I think not even in many colleges, not even in that.
Yeah.
Not even that.
Yeah. So so Linux is a big hurdle even now. Let me tell you, in the industry not so much, but since we are
in the academia, right?
In the
academia,
yes.
Even in colleges, in tier 1 cities, it's a problem.
Yes, yes, because it's not
and
easily.
The country must wake up and have a look at it, right?
Yep, they should. I think it's high time they do.
But then when they combine the power of edge computing with something like a 5G core,
right,
on a private installation and a deep understanding of low latency systems, then you combine IoT, then sky's the limit.
I mean, then you put it in any vertical, right? And I think you just have 101 test cases that will come out. So by test cases, I mean the projects or applications, like you said, use cases. Basically in every vertical that pop out, right? But again, it's not just, how do you say? It's not that we lack the engineers for the solution. It's not that, but it's just that people are still unaware that this could happen. right? Because see, let me tell you, so edge computing as a different concept really well, 5G as a different concept really well, but nobody wants to experiment with both of these and wants to deploy it, especially in the sector that I come from.
That's true, right? Like again, like when I see these systems, right, I see them as one system, right? I see there is a network, and then I see a lot of things plugged on top of the network. So there is a single backbone, and you have a lot of small edge computing devices on top, and each one doing a specific function.
Absolutely.
And they all work together to solve a business problem, right?
Yeah.
So when I mean by these edge boxes, they may be IoT connected to some sensors, or maybe a drone, or maybe an AMR, and all of them, or a camera,
yes,
or a camera, and all of them working together to deliver a use case.
Yeah.
It can be a smart warehouse, it can be a dark warehouse, or it can be a drone in defense, or a drone in agriculture, or a swarm of drones, right? That's where
a swarm of drones is right thing.
It's a different use case.
It's a different use case because I mean, now you're not just adding one drone, because we facing an issue of handover with one drone. You can add multiple drones because 5G does support that. So not only that, but let's just go to the medical side of it, healthcare, right? In the healthcare, 5G does play a crucial role, not in just, there's something called the smart ambulance, right? Smart ambulance tracking system. So the major problem that is pretty much defined over there is that these ambulances, right, they do have, at most, they won't have a doctor, but it'll be somewhat of a nurse or a ward boy kind of a scenario, okay, who wouldn't know what to do, like how to take a proper measurement, right? But if you had sensors, I'm not from the medical field, so, but if you had sensors,
diagnostic tools,
diagnostic tools on board, this could be transmitting directly to the hospital, where a doctor on call could actually be monitoring and could, even tell what medications could be given, or
it's a high bandwidth.
It's
connection.
a high bandwidth connection.
Very high bandwidth connection, and
So this is just in the domain of healthcare. Now you put it in any vertical, right? Commercial, non-commercial, it works out. That's how flexible 5G totally is.
Any specific insight in terms of self-driven cars and 5G? Are there any international
vehicle to vehicle is something that we are currently working on, but it is a thing which also comes in 5G, right? So it works on millimeter wave, right? So it works on millimeter wave, that is for most of the sensing capabilities. Now we do have sensors which work on the millimeter wave, but vehicle to vehicle is more of a, so get this, replace the IoT with cars, so the IoT sensors here are cars, and still 5G becomes the backbone. Okay, so now suppose say we had this the Yamuna expressway, but we do have pileups on the expressway, right? And why do we have these pileups? Because of the natural the fog or several other use cases. But if you had a vehicle to vehicle communication, right, within kilometers of such kind of a thing, we could have a red zone, we could have emergency units deployed, everything could happen.
So I remember watching one YouTube video, like, no more monkeys driving on the road.
Okay. Does it apply in India? I don't know. Okay.
No, the jokes apart. Like I think we refer ourselves to the monkeys, right? Like so, there is this concept of phantom traffic. Okay. Like it's like one driver. He slams the brake. For maybe a cat jumps in, he slams the brake, he slows down, but every car behind him slows down. Then the cat escapes, this guy passes by, but then every other driver will brake at that point, create that traffic snarl, and then they'll continue.
They'll move, right?
They'll move.
Absolutely.
Or even in a signal, it is like this, right? Once the red turns green, it's usually the first car moves, and then they wait, and then the second car moves. And it's not like all the 10 cars start together.
No.
But with vehicle-to-vehicle communication in place and self-driven, so when the signal turns green, all the 10 cars can start simultaneously and go like a train.
Uniformity.
They can travel like a train.
Yes. Yeah. That is something that is also possible.
Probably signals will not be there.
I don't know. In India, I don't know, but sure enough, they shouldn't be there.
Yeah, like if every car is self-driven, then you don't need signals, right?
Yeah, but are we close to that kind of a scenario? Let's fix the potholes once. Okay? Let's first fix the potholes and let's then talk.
I don't talk to people from Bangalore.
Oh my God. Okay. I must shift somewhere else. Okay.
I think, see, there was an interesting video last couple of weeks back, right? Like, see that the reason we have these potholes in all the big cities here, it's the way the administrative structure is organized. So that we spoke about the self-driven cars and how 5G can revolutionize that. And we also spoke about warehouses where these autonomous mobile robots and things. We spoke about drones. And so now coming, I think maybe we can go a little specific into what you do and what your company does.
Right.
Can you tell us, so you are from an R&D organization, right?
Yes.
So can you tell us a little bit about your,
what do we do?
What you do and what technology access you have and how you...
So basically, right, we, like you just correctly said, we are an R&D company. So we manufacture something called generational node base stations. So GNBs. These are your radio units that are actually responsible for propagating the frequency on which your mobiles connect, or your UEs, as we say, they connect. So we manufacture that in India. Okay. So it is our design, our IP that we manufacture. We did have a strong presence in the, we still have a strong presence in the telecom domain. Okay. But we came here to fill this gap that we saw. So basically the gap was actually witnessed during the Bharat 5G. Bharat 5G was a scheme that was developed to establish, for the first time, let me tell you, 5G labs in 100 top institutions all over the country, right?
Predominantly the IITs, they started.
Yeah, I mean, we do have more than 1,000 engineering colleges, but the 100 was the number they stopped at. So
no, I mean it's the initiative that
it's the initiative
that everybody got involved.
So no, that was the okay. So
was that before this?
Yeah, that was before this.
That was before.
That was the okay. So see, that was the point where India as a country decided that, hey, let's stop taking tech from others and let's start building our own. Okay, that is the entire reason why we are here discussing on tech as well, right? Because now it's all about that. It's about we need to create it in-house. In-house. So yeah, like you correctly said, IIT Madras, and there were several other IITs who built a product which was the first 5G lab setup. Yeah, that could be taken, it could be used by several other entities, basically for the purpose of research. So this wasn't made for the telecom sector. Let us clear that first out, okay? So this is where the India's mission came. Let us integrate telecom back into our curriculum. Great thing. So during the Bharat 5G scheme, what actually happened was they were like, why not? Now is a good time. Let's involve the industry. The people who actually know what they're, what they make and what they actually sell out to different countries. Can you do that the same to 100 institutions? So that's where even one of, we also got an idea that, because we have given to 25 top colleges, we were one of those. They have our, GNB setup. They actually have. So we do not, there are two things. A software-defined radio, which also does the job, but a GNB is great when, for all the conversation that we had and facilitates all the IoT, drone, whatever verticals that we just spoke about. GNB is a great solution for those.
So you have this GNB. Again, I'm trying to make sense of the 5G architecture. So if a college wants to make, bring 5G as a backbone for some of their experiments, they call you and you offer them a GNB. But then that's only one piece of a big puzzle.
Okay, that's where again we are different from that, right? So you rightly said, if when a college approaches me, I just don't give them a GNB. Okay, because let me tell you this. An ecosystem doesn't work by just giving you one part of the puzzle, right? And my company, Make My Technology, we build up an ecosystem. Since we are an R&D company, we know what are the requirements of an ecosystem, right? What requires for it to be called as a 5G private network. Now, why am I stressing upon this word, right? I just stress.
So when you mean ecosystem, are you talking about ecosystem of components or ecosystem of companies?
I do mean ecosystem of components.
Ecosystem of components,
right? Okay. Yeah. So because UEs, which are our handsets, they're just a small part. okay, of a bigger picture here. So we just spoke about IoT devices, CPEs, drones, AR, VR.
For people who don't understand the terminologies, an UE is
user equipment.
User equipment. It can be a mobile phone or an IoT.
Or a laptop, it could be a tablet. So basically...
Or an IoT device.
Or an IoT device. But let us just clear the air here saying that, you know, it needs to have a SIM. Okay, please, let's just remember that the main requirement of having something is that you have a 5G SIM. You need a component that facilitates the use of a 5G SIM. As long as you have that, you're welcome to integrate into the solution that we provide you. If not, we also have, not just domains, but we have several other use cases where, you know, we have this IoT gateway that we use. So if you have an existing IoT lab and you want to connect it to a GNB, don't worry, we help you there as well.
So for example, if I have a use case where I'm interested in a 5G, developing a 5G use case.
Yeah.
At this point in time, I don't want URLLC or maybe I'm not even interested in an IoT specific thing. I'm okay with the typical 5G that I use in my handset. But then maybe like I want to use this for a, but I still want to connect an IoT device.
Yeah,
right? Let's
okay.
say IoT device. So what kind of UE do I need?
Okay, shall we just go to the bare basics?
Yeah, do you have some UEs that I can connect to my existing IoT?
I do. Okay. So suppose you have an IoT that you want to connect it with. Okay, so it could be your LoRa module, or it could be a Hello Wi-Fi.
LoRa. Let's take LoRa.
Why not?
Let's
right?
take LoRa.
It is something that is extensively used, right? Even for a home automation project.
Correct.
Right. So this is where we have this board that comes in, which has the back end of a Quectel SIMCOM module that we actually use, and we integrate into this beautiful PCB, which is called the gateway. So you need to have a component such as a gateway to connect to the GNB. So like I said, the module, the Quectel module which we use, is where your SIM is put, and that will be a registered SIM to the GNB. So just like that, you're already connected to 5G.
Okay, and then you also give other ecosystem components where I can then register the SIM against a particular user, and what are the things you do? I mean,
absolutely. Let me try and blow your mind. Okay, you're from the industry. Let me try though. Okay. So since I told you we are from the telecom division, we know what is the requirement for facilitating a phone call, right? So let's say you want to purchase a new SIM, right? What do? You will head up to your nearest store and you will be like, hey, this is my Aadhaar, I need a SIM. And what is the thing they tell you then? They're like, hey Bhagat, you would have to wait for half a day, and then you could use your data services after half a day. Before it was 48 hours, and then it reduced to 24, and then now it's half a day.
1 hour, 2 hours.
1 hour, 2 hours, absolutely, right? But what actually happens behind the scene? Are you aware of what actually happens?
I think you can tell us.
Yeah, absolutely.
Okay.
I mean, that was just the hook, right? So
even if I know, I will say I don't know.
Absolutely, right. So this is where MMT as a whole has designed an interface, this beautiful interface where it's called as a SA core system, standalone core system, where you can register these SIM cards by yourself. Okay, so imagine this, right? You have a research institute, and you already have a GNB. Now, as per our old conversation that we were just having, I think, I told you that 128 users can simultaneously place calls and 1,000 can be registered on this network. So imagine this, you have an, I think 700 to 800 kids. Let's just take that number, right? And every phone has two SIMs, SIM1 and SIM2, right? So you do this, you have students use SIM1 with the registered SIMs, that is to the GNB, and you have your own network inside the college. That's the most simplest use case that's ever been done, right? You can facilitate calls. Now, again, so when we as a company give you these SIM cards, you can allot the services. You can allot them data packs, you can allot them how many hours of calling they can do, you can allot them everything. Right? So on some days when there are exams, you can block all of them, right? Okay. So the internet can be provided over the 5G core. That is also the beauty of the network, right? So
when they are in my premises, you
control the network.
I control the network.
Yes, absolutely. So that is something that works with our system, and just for the sake of the conversation, I am currently speaking about what we provide. So it's the entire ecosystem. from the very basic part. Yeah.
Okay. And yeah, that's one use case. That's an operational use case for an institute. But then let's come to the COEs within the institution.
Absolutely.
So so for example, you also train the faculty, you also train the students. What do you train them on?
Okay, so we have several things, right? So first thing, a GNB and a core, two alien components to anybody. Okay. I mean, it was alien to me for a year or two back. I didn't know that you had something called as a core. And
5G's terminologies even scare me today.
Right. So, okay. I mean, we all can relate to that. Okay. So it is just not about, hand holding them to explain them terminologies anymore. It's about debugging. So this is where a tool that we have created called the MMT COTS platform comes into place. So, there's this very huge company, I'm not going to take the name, but they make chips. They are in the business for a long time. They make a lot of chips. Okay. They came out with a tool for 5G logs. Okay. So they are similar name. So it's a twin pair system, but they have a wired configuration that they use for 5G diagnostics, let's say. Okay. And would you like to, place a bet on how much it would cost for you to purchase one right now, if you would want to? Just say you want to.
It should be in tens of lakhs, I think, right? Like that's
you're somewhere close, so it's it's 20 lakhs.
20 lakhs.
So if you are a hobbyist, better forget even trying to get.
But why would I need them, right? Like see, as a layman, right?
Yeah.
We take these networks for granted.
Yes, we do. Yes,
we do. We take these networks for granted. Like when somebody says, "Oh, I want 4G and I need to test something about it."
Yeah.
I need to see the logs. I don't really make sense of it. Right?
Yeah.
Can you break it down for the layman?
Yeah, for the layman level, right? So when I talk about having a diagnostic tool, why would I even have a diagnostic tool? Several times when suppose say we already have connected the IoT device. Okay, but for some reason we are not having data throughput from the IoT gateway to the GNB or from the IoT gateway to the IoT device, right? That is when you need to debug. And being in the country we are not so Linux friendly. Okay, so this is where these tools such as the one which we make, MMT COTS, comes into place, where these are wirelessly connected to our platform, by the way. So you don't need a wired configuration. You can just using their IP, you actually you register them on the network, and this is, by the way, you can do multiple. So we don't put a limit on these, and you can debug them on every layer. So there are 3 layers, L1, L2 and L3. So you can debug them on every layer and study the protocol charts.
Even on L1?
Yes.
Okay.
Yeah. So that's the physical layer, right? Yes, you can.
Okay. So we can realistically debug something. Say if I have okay. For example, if somebody in an institution, they wants to play around with a very complex use case. Let's say URLLC. I don't know whether you're offering it now. An URLLC type of a use case, and then they see that things are not working, or things are not working as they expected.
Yes.
Or one, I mean, with respect to URLLC, I know that I don't know the term. I hope I'm using the right terminology. The packets are sent in multiple paths, right?
Yes, they are. OFDM is what 5G uses. Okay, so yeah, between the L2 and the L3, right? So you have a shared channel which it goes across. So you could see across the channels and analyze the packet flow, right? It's only through these diagnostic tools could you actually see that if the packet is being sent or is it not. Because in the live network, right, with 5G, since the latency is so less, the request needs to keep on going repetitively. Okay, so at any point in real time, if there's a breakdown, you could analyze on the timestamp what is happening.
And these colleges are using it. I mean, people who have got this, they are using it.
Some of the big names, I think, in the top tier colleges also use it.
So you may get a call from a student team saying, hey, we are trying to build this and it's not working.
Yeah.
And we are trying to use this diagnostic tools. Can you please help us make sense of what is happening?
Yeah, sure enough. I think MMT is made for those kind of scenarios, because let us be clear on one thing. Okay, the industry standards are quite different, and the research and engineering college standards are way different. Okay, now I'm not just talking about financial terms here. Let's throw financial terms out of the window. But the understanding of the two are way apart.
way apart.
Way apart. Okay, we need to first close that bridge, close the gap. Okay, now I do know that we have been trying to do this for a couple of years now, so it's not something
Ages.
new. Ages, right? So the only thing is that you push the technology from the industry into this thing, which hasn't been done before. I mean, we have tried it through centers of excellence, but again, that is where the training comes in place, right? The hands-on training. Let me just tell you that. So I primarily don't believe in a theoretical learning approach. Okay, as I earlier said, break the system. We support in that. So Make My Technology doesn't actually have this fee that the other industries have. So it's a particular cap that you have to pay if you break the system. We don't. We actually encourage you to break the system unless you actually take a baseball bat and break it. Don't do that. But you're all open to go crazy on it.
Okay.
Yeah.
So you bet on the kind of support you can give us.
I mean,
right?
yeah, that is our lifeline. Yes, we do.
How are you planning to take this forward, right? Like you are here today,
Yeah.
and what is your roadmap? How does it look like?
Okay, so great question. Okay, I've been waiting for this. So what we first began with, right, was setting up these 5G labs, which we have done with premium institutes. It's already done. So now comes out this beautiful project, which is building, I think, India's first 5G SA core. I think I'm right to say this, okay? Because a telecom grade core, right, it requires 3 backups. You must know this, right? So in the industry, it's all about backups. Because you cannot at any point of time tell that for 100% assurity that the system would work, right? 24/7. But it is very rare that the telecom fails, right? It's because of things like this where we have 3 backups. So we are trying to create such kind of a product. It is in the making with 2 premium institutes. And I think where we are would also be, joining this beautiful project along with MMT. And we are heading towards the direction where we're going to be patenting this with the students and the faculty involved in this.
Wow.
Okay. So that is a revolutionary step that MMT is taking forward. So we are not just making a product here to sell back. Okay. We are not commercializing this. We are actually making sure that we educate the people that, hey, because see, it's quite, obvious that after 4 years of engineering, your parents do ask you, what are you going to do? Right? We paid your fees. What are you going to do?
What is the return on investment?
Yes, the ROI, right? Let's not get into business terms. So basically the roadmap, getting back to the roadmap. So this is one of the things, this is in the making. It is happening. It's going to take us around like 5 months, maybe, okay? 5 to 6 months to actually, for us to come out, and we are going to, not just put it on the shelf, right? We are going to introduce it to the government also. We have, because we come from 13 years of R&D in the telecom, we have made connections and we are proud of those connections. And we want to introduce that relation in the, in this beautiful community of faculties, teachers and trainers. So that's one part. The second part is that we have also integrated ourselves into this training programs that we run. We run it from our office, which is in Bangalore. Okay, so we have this collaboration which is called as the VTU VRIF TCOE, right? So you must have heard of TCOE, right? Okay, let me just give you
new term for me.
Yeah, so TCOE is the Telecom Center of Excellence. Okay, so the telecom, so the Department of Telematics, DOT, has also taken a very crucial role, plays a very crucial role in educating people in terms of not just 5G, but any of its, telecom counterparts. Okay, so we are part of this beautiful collaboration with VTU, which is Vishweshwara Technological University. So we are, based out of that, the HQ over there, which is in Nagarbavi, Bangalore. So over there, we also do in-house trainings where they come, they work for, I think, for 1 day. We have a 1 day certification course. Okay, we have a 1 day certification course that you come, and it's 80% of hands-on. So don't expect us to open a PPT and then explain you the PPT. It's you come, you get this license of the MMT COTS that we ourselves have developed in-house. And then on that, you actually start working the system. You start debugging the system. Okay, so what happens when a phone call is made, right? You see the logs and you try making sense of it. So that is the basis of what you need to understand. Okay, so that is also another roadmap. And now coming back to something that's a very big project called Kavach. Have you heard of Kavach?
Yeah.
Yeah, so you must be aware of the TCAS system, right?
trains.
Collision avoidance system,
Collision
right?
avoidance
So that is by itself a vertical that I don't think colleges prefer. Would I be right to say this? I mean, the railways is somewhat of a expensive vertical,
Yeah.
right? The I mean, I
As an
have
infrastructure, it's
Yes.
we tend to among many things that we take for granted. That's also one thing we
do,
take for
right?
granted, and we often forget the engineering that goes behind.
Yeah, I mean, when you say that, you're completely right, because we are, I have seen colleges invested in the agriculture. I've seen them invested even in defense, right? Several colleges do make products for defense. But when I speak about railways or the mining, these are two, I'll not say forgotten, but untouched verticals. Okay. So we actually have a physical line between Secunderabad to Bidar, 50 kilometers, on which we run we have a working understanding with the Department of Railways, where we're developing a TechAS system. So there are three, verticals of this problem statement. One is called the bogie management system, where we use the LoRa. So it's an IoT use case. Okay, that is now going to be deployed in real time.
LoRa plus 5G.
Yes.
Yeah, okay.
LoRa plus 5G,
LoRa
the
plus
best
5G.
combination. Okay. That is one. Another is called a disaster management system. So I think you must remember last year, Odisha, 2 trains collided, and that's in 2025, right? I mean, I particularly think that even in this day and age, I don't think we should be having accidents like that when Japan's making locomotives that go really fast. So again, MMT is trying to build a project for that. Okay, so 2 things. One, to avoid that. Okay, using the 5G. So we are trying to replace the existing system which makes use of RFID tags with our GNB solutions. Okay, so that we ensure that quality of service is also maintained, and on the same time, any SOS signal that needs to be sent can be also sent using that. So coming back to disaster management, have you heard of something called network in a box?
Yeah.
Yeah. So your
5G can be a network in a box.
Yeah. And put in your backpack and you can just walk. Yeah. MMT makes that. So we have that configuration available with us also. So having an R&D background makes us flexible to the requirements of the industry.
Probably defense will be one of your
yes. So that is basically the roadmap that we have set upon, because we want to work extensively with universities and Indian institutes, okay, and develop a really big ecosystem to make great products possible. Let me use the word possible. Yeah.
Okay, nice to hear that.
Yeah.
And how has been your stay in our town?
Okay, I mean, this is the second time I'm coming to Tamil Nadu. So the first I was in Chennai. So this college called Weltech University. Okay, before that, let me just tell you, I think whenever I come to Tamil Nadu, it's very heartwarming to meet the people, because I do not know why, but I am greeted well. Okay, I am greeted well by all of them. So I am currently in the talks with I think 3 institutions, including the one which we are at, and every time I do realize the people who I speak over the call, right, they have this sort of humble nature when they're talking to you, right? Because it's not just referring you as sir or but even the tone of their voice is quite humbling. So that said, but SSM has taken great care of me and my team. I mean, surely I would love to come and visit multiple times. So, and the food is too good, delicious. Yeah. I mean, the biryani, obviously. Yeah.
Did you get to taste some Dandakal biryani?
Yeah, yesterday, last night I think we were taken out by the team, and we had a stomach full. Yeah, it was really well, I think.
Okay, so it was nice talking to you.
Yeah.
Hopefully we'll get to meet more often.
Yes, I hope so.